Hi everyone, welcome back to the second Chemistry 30 podcast of the week. We're now working on writing balanced half reactions. Once again, there is a step-by-step process to this that I highly recommend you listen to a few times, follow through a few times so that you can figure out what's what step by step. Please do have your printed notes handy so you can see what I'm referring to, because I'm going to keep talking about the steps. I have them written out on here so you can see they're on the third slide, but I'm going to be referencing the sheet constantly. So this is our first example that we're going to go through those steps with. And the very first one here is you have to divide the equation into two half reactions. So here's what's different. This is already in some sort of a reaction. It's definitely not balanced yet by any means. So that's going to be the key start. When you do this, look at the entities present and recognize that if this one has chromium, I'm going to have to include this other chromium in the same half reaction. Hopefully things are starting to make you go, oh, okay, I can kind of see this. Check out the scandium. If scandium is a reactant, this scandium ion is going to have to be in the product. So now between those two colors, you can start to see our two half reactions. So this is going to be step one. Now, at this point, it's really hard to tell which one's oxidation and which one's reduction. So we're not going to be able to split those up yet. But we can still begin the process. So Cr2O7, 2 negative. Now here's what's a little bit different when you do this half reaction versus the past. You don't know at this point what else is going to be reacted, what else is going to be product. So give yourself a whole lot of room. Write the arrow quite a ways over before you put the chromium 2+ on there. Okay, that's the beginning of the first half reaction. Our second half reaction is, of course, going to involve that scandium. So we're going to have the SC solid. Again, give yourself a nice long space before you put the arrow to the SC 3+ aqueous. And honestly, that's all there is to it for step one. When we start to move here into step two, so let's continue the process. Now we're going to do step two. Step two means that we have to balance all the major elements. Do not touch oxygen and hydrogen at this point. Looking through, you can see we've got two chromiums on this side. I have to make sure then that I have two chromiums on this side as well. Things have to balance out. Otherwise, it doesn't make sense. So 2 and 2. Check out the scandiums. Scandium's good. We've got one of each. No big deal. That's all there is to step two. Moving on to our step number 3. Okay, so step 3 is balancing out the oxygen atoms. And we have to look at both of our half reactions when we do this. So glancing through, you can see that we have a total of 7 oxygen atoms going in on the left side here. We need to get oxygens being produced as well. And the way we do this is by adding water. Why? Well, guys, these are aqueous environments. If they're aqueous, then water is present anyway. Of course we can add more water. 7 oxygens going in means that I'm going to have to add a total of 7 waters coming out. Okay? Because there's 7 oxygens in those 7 waters. For the second half reaction with the scandium, no oxygen is present, so no big deal. I don't have to worry about that. Moving on to step number 4. Step 4 is considering that, hey, you just added in some good old hydrogen. And you added in 14 of them when you put those waters on. So we have to account for that. To account for that, you're going to go back over to this side and we're going to add in 14H plus aqueous. Now here's the deal, guys. When you're writing these balanced half reactions, every single one of these, in terms of the ones that we deal with, are going to be acidic conditions. Now, if we'd been doing this in class, we would have talked about a few more scenarios besides just acidic conditions. But for the sake of the fact that we're doing this Distance learning style, we're only going to focus on the acidic. Okay, that's step 4. Done and done. If you look at these two, at this point, it's still impossible to actually tell which one is the which one is the reduction reaction and which one is the oxidation. So that's where we get to step 5. Step 5, you need to glance through this and figure out, okay, what's actually happening with the electrons. And to figure that out, look at each side and look at the total charge. So on this entire side, I've got positive 14 contributed by those H pluses, and on the Cr2O7, I've got a total of negative 2. Positive 14 plus negative 2, there's a total charge here of positive 12. So if positive 12 is my total charge on this side, if I go over to the opposite side over here, then I'm going to have on this side, well, similar thing, look at the total. Water contributes 0, whereas the chromium over here, 2 times 2 plus, this is contributing a total of 4 plus. All right, I need to have the same charge on both sides. Positive 12, positive 4, those two don't balance out. So all I can do is add electrons. From an adding electron perspective, I can add, well, electrons to the left-hand side. If I take this and I add a total of 8 electrons over here, think of what happens. I now have positive 12 being added to negative 8, which, hey, I get positive 4. That's what we want. Now we have positive 4 on both sides. I've just determined that this one is my gaining of electrons. This is my reduction half reaction. That means that on the other one, this must be oxidation, which gives you a little cheat to know if you're doing it right. Well, check the charges. Scandium on this side has a total charge of 0. On this side, the total charge is positive 3. Well, how do I get that to 0? By adding 3 electrons. Good news is that's an oxidation reaction, so that's good then. One of them's gaining electrons, one of them's losing electrons. We have now just finished your step number 5. Okay, last step here is that you need to make sure that everything balances out and cancel things out in turn. So step 6, if we're going to balance these out, look at the electrons. The top one has positive 14, the top one has 8 electrons going in. The bottom one has 3 electrons, so here's our 8, and here's our 3. 3 electrons being produced. If this is going to work for those to balance out, we're going to have to find the lowest number that 8 and 3 both go into. Now, in this case, honestly, we're just going to have to multiply the top one by 3 and this bottom one by 8. Okay, last step, get that redox. This one's a little bit easier because the only canceling out and simplifying is going to involve electrons. It's not going to be a big deal for the rest of them. Don't forget to multiply though. So we have 3 of our Cr2O7 2 negative aqueous. And this is going to be added to, watch your multiplying here, we have to do 3 times 14. So we're going to end up with 42 of our H plus. Aqueous. Keep on going. We're going to have also going in, don't forget about the scandium, 8 SC solid. Electrons have canceled out. Produces. Okay, there were 2 chromiums produced before. 3 times 2, we're going to have 6 Cr2 plus aqueous being produced. We had 7 waters being produced before. Times 3, we now have 21 waters that are being produced. Plus, we had 1 Sc3 plus ion before. Times 8, we now have 8 Sc3 plus aqueous. And there it is. That is our net redox reaction. Again, think about what's happening with those electrons. When we times that 8 by 3, there were 24 electrons here. When we times this 3 by 8, I had 24 electrons there. That means that those 24 electrons cancel out, and those 24 electrons cancel out. That's our ultimate goal when we're trying to balance these. Okay, so step by step in terms of what we actually did. We divided the equation into two half reactions. But at this point, when you're going through it, you cannot label yet. So don't label as oxidation and reduction yet. Okay, we know that they're going to be oxidation reduction. We're just not sure which is which at this point. When you balance the major elements, that's your next step, but make sure that you leave out oxygen and hydrogen at this point. Don't touch those. Step 3 is where we balance our oxygen by adding water. So we always use water to balance oxygen because we've got lots of water present. Step 4, assume acidic conditions. We're going to balance the hydrogen atoms by adding that H+. H+ is present because, again, we assume acidic, whoa, come on, pen, conditions. Okay, next step. We add electrons to balance out charges. And this is where you have to focus on what charge is on the reactant side and what charge is on the product side of each half reaction. Once you've done that, balance the electrons between the reactions so that you can add them together. And remember, at this point, you're going to have to simplify. So a lot of times we end up canceling out different chemicals. The electrons are canceled out as well, of course. Okay, let's try another one of these things. You have this example in your notes too. Oh, I see that this one did something funny here. This, folks, of course, should be an arrow here on my sheet. Okay, check it out. Notice acidic conditions is being mentioned here. That's important because that means H+ is going to be an option in helping us balance. Notice something else. This is kind of weird. Sulfur is not written as S8. It is possible for sulfur to be present individually. It doesn't happen as often. S8 is more common, but in this particular reaction, sulfur is reacting as an individual. So, take note. Remember, in chemistry, you're only getting just the tip of the iceberg. There's so many other scenarios that exist. Now, when we start writing these out, we do not take note at this point if we have oxidation versus reduction, which is which. Guaranteed we'll be able to figure it out later, but for now, just split it up. Sulfur is here, sulfur is in this product, so those two are going to have to go in the same reaction. Here we have something with nitrogen, here's the other one with nitrogen. Those two are going to have to go in the same half reaction. Start writing them. Remember to split things up. Sulfur solid, give yourself lots of room, is going to produce SO2 gas. Same thing for the second half reaction. NO3 negative aqueous, give lots of room, is going to produce NO gas. Step 1 is complete. Step 2, check out all those different atoms other than oxygen and other than hydrogen. See if they need to be balanced. One sulfur, we're good. On the second one nitrogen, we're good. Step 2 is done. Step 3, start to balance out those waters. So I'll put in a different color just to clarify here. When we balance out with water, we're looking at oxygens. I have a total of 2 oxygens that is produced here, which means I'm going to have to add 2 waters on this side to make sure that I have 2 oxygens going in. You can't create matter. That's what this is coming from. If 2 oxygens come out, 2 oxygens have to go in. Okay? Look at the second half reaction too. This one has a scenario we need to pay attention. There are 3 oxygens that are reacting and only one that is produced. So we're not going to try to put a number in front of the NO because that's going to mess up the nitrogen. Instead, we're going to use water because they're aqueous. We've got lots of water present. So we need 3 in total. There's already 1. I'm going to add an extra 2 waters on this side to balance out. Now we've got 3 oxygens going in, 3 oxygens going out. Step 3 is finished. Moving on to step 4. Step 4 is where we got to make sure those hydrogens balance. So notice now in the first reaction, I've got 4 hydrogens reacting. That means I have to produce 4 hydrogens on the right-hand side to balance things out. I'm allowed to do that because we have acidic conditions where H plus is present. Okay, second half reaction, same thing. There are 4 hydrogens present in the water produced, so I have to add 4 hydrogens reacting on this side. All right, step 4 is now complete. Step 5 is that one that gets a little bit more complicated when you have to look at total charge. Look at the top one. If you look here, we have a total charge at this point of 0. On this side, we have a total charge here. You got to times by things. We've got 4 positive H pluses. So the total charge over here is positive 4. Okay, how do we balance out a positive 4? Well, only by adding electrons. That's all we can do. If I put the electrons reacting, I'm going to have negative 4 and positive 4. Those don't balance out. They're very different. Instead, I have to put my 4 electrons produced. Positive 4 plus negative 4 equals 0. Now we're balanced. We also have now figured out that this is an oxidation reaction. You have the electrons being lost. Okay, that gives you a cheat. The bottom one with nitrate is going to have to be gaining electrons. All right, look at total charge. On this side, my nitrate contributes negative 1. My hydrogens contribute positive 4. Negative 1 plus positive 4. We have a total of positive 3 on this side. Check it out on this side. We've got a total of 0. Okay, so how do I get positive 3 to 0? I add 3 electrons. All right. Indeed, it gained electrons. It's reduction. We're on to the last step where we need to balance out those electrons. Going through this, have a look. I have a total of 4 electrons being produced in the oxidation reaction, 3 electrons being gained in the reduction reaction. To balance those out, I'm going to multiply the top reaction by 3 to get it to 12 electrons. I'm going to multiply the bottom reaction by 4 to also get it to 12 electrons. Okay, 12 electrons, life's good, they cancel out. We're ready for that total redox reaction. Again, at this point, these are fairly simple, but we've got a little bit more canceling out that's going to happen. I want you to look at this. We have waters being reacted and waters being produced. So in actuality, maybe we should take a step back from the redox and just simplify things a little bit. Check out that oxidation reaction again. Let's rewrite it. We now have 3 scandium solids plus there were 2 waters, so now there's 6 H2O liquids, which is going to produce 3 SO2 gas, plus we had 4 H pluses, so now we have 12 H plus aqueous, and our 12 electrons being produced. The reduction reaction, vice versa, we had 1 nitrate, so now times that by 4. We have 4 nitrates, plus there were 4 H pluses. So now 4 times 4, we've got 16 H plus coming off of there. And 3 electrons before, now there's 12 electrons going in. Produces 1 nitrogen monoxide gas before, times that by 4, we've got 4 NO gas. Plus, there was 2 waters before, now there's going to be 8 waters being produced. When we get to the redox reaction. Think about the canceling of things. Definitely my 12 electrons cancel out. That makes perfect sense. But glance at the waters. If I have a total of 6 waters going in and 8 waters coming out, then the way I go through this is I take my 6 and cross it out completely because they're gone. On this side, there's no longer 8, and I write how many are left. 2, right? 6 go in, 8 came out. That leaves, when you cancel out, 2 left. Goes through a similar process with your hydrogens. If I had 12 H plus being produced and I had 16 that were being reacted, that means my 12 are completely gone. How many are left here? Well, 4. So you see there's a bit of work going through it. Redox, now we need to simplify. 3 scandium solid. Those 6 waters are gone. Don't write them down. Plus 4 NO3 negative aqueous. Plus, not 16 H plus, but only 4 of them. 4 H plus aqueous produces 3 SO2 gas plus, take note, those 12 H plus are gone. So are the electrons. So we're down to 4 NO gas plus, again, not 8 waters, but 2 H2O liquid. And that, folks, is the net redox reaction. In terms of complication, I'm not going to make them really any harder than that one. So when you have to do a little bit more canceling out is about as hard as it's going to get for your Chem 30 distance learning. One more question for us to do together. Check out this one. Again, you need to make an assumption that these are happening in acidic conditions. Alrighty. Now, when we balance these, similar type thing, that your step 1, when you go through it, is pick out where things go together. We've got manganese in this one, so it's going to have to go in the same reaction as the Mn2+. And we have here our C2O4 2 negative. It's going to have to go in the same reaction that also has the carbon. Hopefully the colors can help you see where these go. Don't label oxidation and reduction yet. Leave space. MnO4 negative aqueous is going to produce Mn2 plus aqueous. Second half reaction. C2O4 2 negative aqueous is going to produce carbon dioxide gas. Step 1's complete. Balance anything that is not oxygen, not hydrogen. In this case, carbon needs to be done. So I've got 2 carbons being reacted, which means I'm going to have to produce 2 carbons on this side. If 2 go in, 2 have to come out. Keep going. Non-oxygen, non-hydrogen is done. Move on to oxygen. We balance oxygens with our waters. There's 4 oxygens being reacted, none produced on that top half reaction. How do we deal with that? Well, we got to add 4 waters to account for those 4 oxygens. Look at the second half reaction. In this one, don't lose sight of what's going on. You have 4 oxygens going in, but you actually already have 4 oxygens coming out. 2 times 2 is 4. So that one's done. My waters are ready to go on the bottom. I don't need to add any in. Okay, work on the hydrogens. Hydrogen on top, I've got 8 of them that are being produced, 4 times 2, which means I have to react 8 hydrogens as well. Step 4 is now done. Move on to start to look for those electrons. Again, pay close attention to this. This is the most common spot that mistakes are made. Be careful with how you number crunch. Remember your integers, positive, negative. So we have positive 8 total plus a negative 1. Positive 8 plus negative 1. This side has positive 7. Okay, on the right-hand side, water has a charge of 0, but there's a 2 plus with the manganese. So this side has a total of positive 2. Positive 7, positive 2. I need to get my left-hand side also down to a positive 2. How do I do that? By adding 5 electrons. I now just found out that this is my reduction reaction. My second reaction has better be oxidation. So I'm going to be needing electrons to be produced, right? To be lost. Look at total charges to make sure you're right. Total charge on this side is negative 2. Total charge on this side is 0. Okay? Oh, then that works out great. Plus 2 electrons over here. I now have negative 2 on both sides, and this was oxidation. That's good. Step 6, we need to create our redox equation by balancing out electrons. I have a total of 5 electrons being gained and 2 electrons being lost. To balance those out, we're going to multiply the top equation by 2 and multiply the bottom equation by 5. Notice with these, there's not as much of a complication with H plus and water, which means I can skip without doing any extra work right to my redox equation. Don't forget to multiply though. We have 2 Mn O4 negative aqueous. And then I have my 8 hydrogens times 2, so plus 16 H plus aqueous. Plus, I have 5 C2 O4 2 negative aqueous. Produces, I multiply that manganese by 2, so I've got 2 Mn2 plus aqueous. There were 4 waters, now there's 8 H2O liquid. I'm going to need to add that to my 2 times 5, 10 CO2 gas. And there you have it, our final redox equation, all balanced out. My electrons ended up canceling out because I had 10 going in, 10 going out. We're done. You guys need to please continue on with the homework. So number 2 from the weekly assignment, A through D, is extra practice with all of this. As per usual, if you have questions, email me. I will do my absolute best to help you out. Miss you guys. Take care of yourselves. Bye-bye.